We now discuss the solution of a problem from the section Coordinate Geometry, and the problem is on the tangents to a parabola, and this question has appeared in the joint entrance examination main held on 24th June 2022 in the first session. The problem is, if two tangents drawn from a point alpha comma beta lying on the ellipse 25x square plus 4y square is equal to 1 to the parabola y square is equal to 4x are such that the slope of one tangent is 4 times the other, then the value of 10 alpha plus 5 whole square plus 16b square plus 50 whole square equals. And we have the ellipse 25x square plus 4y square is equal to 1. On it, a point alpha comma beta is taken, and two tangents are drawn from this point on this ellipse to the parabola y square is equal to 4x, such that the slope of one tangent is 4 times the other. Then we have to find 10 alpha plus 5 whole square plus 16 beta square plus 50 whole square. The value of this is to be found. We now discuss the solution of the problem in detail. We have the ellipse 25x square plus 4y square is equal to 1. Putting this equation in the standard form, we get x square by 1 by 5 whole square plus y square by 1 by 2 whole square is equal to 1. It is of the form x square by a square plus y square by b square is equal to 1. Given the point alpha comma beta is on this ellipse, now then alpha will be equal to 1 by 5 cos theta and beta is equal to 1 by 2 sin theta, taking the parametric representation of this ellipse. So the point on it, we have the parametric representation like this. The equation of the tangent to the parabola y square is equal to 4x is given by y is equal to mx plus a by m. Y square is equal to 4ax, that is the standard form, and a is 1 here. So y is equal to mx plus 1 by m. Now, given two tangents are drawn from this point alpha comma beta to the parabola, therefore alpha comma beta lies on these tangents, therefore alpha comma beta is satisfied by this equation. This equation satisfies this alpha comma beta. So substitute y is equal to beta, x is equal to alpha. In this we will get beta is equal to m alpha plus 1 by m, and clearing the denominator, then you will get alpha m square minus beta m plus 1 is equal to 0. And let this being a quadratic in m, let m1 and m2 be the roots of this equation. We are given m2 is equal to 4m1. We are given the slope of one tangent is 4 times the other, therefore m2 is taken as 4 times m1. Now, for this quadratic equation, m1, m2 are roots, therefore m1 plus m2 is equal to the coefficient of minus the coefficient of m by the leading coefficient, that is beta by alpha, and the product of the roots is equal to m1 m2 is equal to constant term by the leading coefficient alpha. So thus we got m1 plus m2 is beta by alpha, m1 m2 is 1 by alpha. Now we have m2 is equal to 4m1, so m1 plus 4m1, that is 5m1 is equal to beta by alpha, and this is m1 into 4m1, that is 4m1 square is equal to 1 by alpha. Now 1 by alpha is equal to 4 times m1 square, Now 1 by alpha is equal to 4 times. From here m1 is beta by 5 alpha. Therefore you will get 1 by alpha is equal to 4 into beta by 5 alpha whole square. So eliminating m1, we will get 1 by alpha is equal to 4 times beta by 5 alpha whole square. We continue in the next slide. So the element of m1 from the previous slide, 1 by alpha is equal to 4 times beta by 5 alpha whole square. Remember that alpha is equal to 1 by 5 cos theta and beta is equal to 1 by 2 sin theta. And we have to find the value of this 10 alpha plus 5 whole square plus 16 beta square plus 50 whole square. Now, this will imply 1 by alpha is equal to 4 beta square by 25 alpha square. So, alpha 1 by 25 alpha square is there. Cancel alpha, you will get a 25 alpha in the denominator, and taking cross multiplying, you will get a 25 alpha is equal to 4 beta square, that is 2 beta whole square. And now 2 beta is equal to sin theta. Beta is equal to 1 by 2 sin theta. 2 beta is sin theta. So 2 beta whole square is sin square theta. Let's call this as the equation 1. And for sin square theta, we have written 1 minus cos square theta, and that is equal to 1 minus cos theta from here 5 alpha. So this will be cos theta is 5 alpha. So cos square theta is 25 alpha square. So 25 alpha is equal to 1 minus 25 alpha square, and this will give you a quadratic equation 25 alpha square plus 25 alpha minus 1 is equal to 0. Now the value of alpha you can obtain here. Alpha is equal to minus b plus or minus under the square root of b square minus 4ac by 2a, and that will be minus 25 plus or minus under the square root of 25 square minus 4 times a, that is 25 into c minus 1 by 2 into a, that is 25. So now simplifying all these things, you will get minus 5 plus or minus under the square root of 29 by 10. Cross multiplying, you will get 10 alpha is equal to minus 5 plus or minus root 29. And you will get from this 10 alpha plus 5 is equal to plus or minus under the square root of 29, which is there in this one. That is, we want to find the value of this. In that 10 alpha plus 5 is required. So that is there. Now 16 beta square, we will try to get 16 beta square. Now 16 beta square is equal to 16 beta square is equal to 4 sin square theta. 4 sin square theta. And now beta is equal to 2 beta is sin theta. So 4 beta square is sin square theta. So it is 16 beta square, that will be equal to 4 times sin square theta. And for sin square theta, go back to equation 1, it is here. Sin square theta value is 25 alpha. So that will be equal to 4 times 25 alpha, and that is 100 into the alpha value is minus 5 plus or minus under the square root of 29 by 10. Now clear the denominator. 10 tens are 100, that is equal to 10 into minus 5 plus or minus under the square root of 29 multiply minus 50 plus or minus 10 root 29. We want 16 beta square plus 50. So minus 50, send it to the other side. You will get 16 beta square plus 50 is equal to plus or minus 10 root 29. So these things, and now square them and add. So 10 alpha plus 5 whole square, 16 beta square plus 50 whole square is equal to plus or minus root 29 whole square plus or minus 10 root 29 square whole square, and that is equal to 29 plus 2900, and when added we will get 2929, and that is our required answer. So That is the discussion of the solution of the problem from the coordinate geometry, and it is on the tangents to a parabola. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.